What's up, everybody? Thanks for tuning in to another episode of Math Chat with Mr. Richardson. Thank you to all my YouTube subscribers, all my students on Edpuzzle, everyone taking the time to view this video. Make sure you hit that like or subscribe button there at the bottom. Anyways, today we're going to talk about how do we take a sum or a difference to a power. If you haven't watched my earlier videos on how do we take the product of monomials or how do we take a power to a power, go back and watch those videos. Let's get right into it. In our last episode, we learned how to take a product to a power. I may have even showed you this same question. When we take a product, like 3 and x cubed, when we take that product to a power, they both get the power. 3 gets this power of 2, as does x cubed. If they both get the power, it should look like this. 3 to the power of 2, that's a base of 3. 3 times 3, or 3 squared, is 9. And when you take a power to a power, you multiply. So this 3 and 2 here, because they're both exponents and not a base like this one, I will multiply them and get x to the 6th. 9x to the 6th would be the equivalent expression here. Now I'm going to show you here what not to do. Not the correct way to do it, but what not to do. And some people believe here that now I have a sum. Notice it's not a product. They're not being multiplied. I have a sum to a power. Most people do this, and this is so wrong. Never, ever, ever do this. They go like this and distribute the power. That is so bad. Terrible. If you do that, you would get something like this. I shouldn't even be showing this. This is just terrible. No, 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 never, never, never do that. No. And you might say, why? Why is it not correct? Why can I not take a sum to a power like that? And I know a lot of people have made this mistake. And let me break it down for you with easier numbers to show you why. Imagine I just look at these numbers here. Here I have a sum to a power. 3 plus 5, that's sum squared. And I'm going to show you why you may not just distribute the power. This is, again, the wrong way to do it. If I distribute the power here, what I would end up getting is this here, 3 squared plus 5 squared. Well, actually, that's this one here, the bad one. 3 squared plus 5 squared. 3 squared is going to be 9. 9 plus 25 is 34. Of course, that is not the way to do the problem. No, no, no. What you're going to see is if I had actually added them, 3 plus 5 would have been 8. 8 squared would have been 64. And you can see that these two things aren't equivalent. This is the correct way to do it. So what's end up happening here when you do it this way is you're missing out on a term that I like to call the 2ab term. Essentially what you're missing out on is 2 times whatever the a term and whatever the b term here is. Here the a term is 3 and the b term is 5. So what you're missing out on is 2 times the a term of 3 times the b term of 5. 2 times 3 would be 6. 6 times 5 would be 30. And if you can see, that's what they're separated by. They're off by 30 because you forgot this 2ab term. So let me show you how we can go back and solve this problem here, number 2. Well, if I want to solve this problem here, what you have to do is what's called double distribute, or sometimes double distribute is referred to, as you may have heard, FOIL. FOIL is just an acronym, meaning it stands for, each letter stands for something. It stands for first, outer, inner, last, which is the order that you double distribute. Let me explain to you in detail of how to do that. First step is you have to take this binomial, or two terms, or this sum, and you have to write it twice because of the square. Once you've now written this sum twice, you can double distribute, also known as foiling. To FOIL, what you would do is you'd first multiply the first terms. The first terms are 3x to the third and 3x to the third because they're both in the front, so they're first. When you multiply pieces with the same base, add the powers. X to the third and x to the third, if I add those, become 6. But here I need to multiply those 3's, they're regular numbers. My first term would be 9x to the 6th. Next, you multiply the outers, 3x to the third and 1. Those would be the ones on the outside, which I could maybe designate with an hour like that. 3x to the third times 1, or anything times 1 is just itself. Then you'll multiply the inner terms. The inners are 1 and 3x to the third. Anything times 1 is really just itself. And finally, you'll multiply the last terms, 1 times 1, which is just 1. In a last and final step, what you have to do is, this is really the answer here. This is an equivalent expression, but we want to simplify it. There are some like terms. 3x cubed and 3x cubed are like terms. When you combine them, just add the coefficients and keep the variable piece the same. Those would combine to 6x to the third for a final answer that looks like this. Now, for all purposes, when you're actually doing this yourself, and I'm not sitting here explaining it, this step here really never happens. If you want to do this step now, because it helps you at the beginning, that's fine. But really what you're doing when you do this is you're just drawing an arrow one at a time. And when you draw an arrow, I would first draw the first arrow, and then I'd write this term. Then I'd draw the outer arrow here, and I'd write this term. The inner arrow, I'd write this term. And the last arrow, and I'd write this term. I'm not at any point writing out these products. This is taking place in my head, and it's taking place as I signify drawing the arrows. 1, take the product. The next one, take the product, and so forth. Let's see if you can try one of these on your own. See if you can figure out what this difference is to the power of 2. Well, you may have guessed it. In order to do this, you need to rewrite x minus 4 twice because of the square, and then double distribute or FOIL. The first thing you do is do the first terms, x times x, which would be x squared. Then you would do the outer terms, x times negative 4, or negative 4x. Next, you would do the inners, negative 4 times x, or negative 4x. And finally, the last terms, negative 4 times negative 4, or positive 16. Now just combine like terms. Negative 4x and negative 4x combine to negative 8x. Again, if you're doing this on your own, if you don't need to do this step here where you write out the products. Too much work. Where is it? There it is. These ones. Don't write out the product. Just write the arrows and go straight to what the solution is right here. Let's try another one. See if you can figure out which expression is equivalent to x plus 3 squared. First step is to rewrite this sum squared as the product of two binomials. Now we're going to double distribute or FOIL. X times x for the first terms would be x squared. Then the outers, x times 3, 3x. Inners, 3 times x, 3x. Lasts, 3 times 3, or 9. Combine like terms, 3x and 3x become 6x. See if you could try this one. This one's a little more difficult because now you have some exponents inside the parentheses, but the process should be similar. Rewrite this as two binomials times each other. Now just go through the double distribute or FOIL process. First is a squared times a squared. Remember, when you multiply things with the same base, you add the powers. 2 plus 2 is 4 for a to the 4th. Now you're going to do the outer terms. A squared times b squared. You might be tempted to add these exponents, but these are different bases, so they don't really do much. They just stay as a squared, b squared. Now multiply the inner terms. B squared times a squared. Same product as the last one. The order is just reversed, so I'll just write it as a squared, b squared. We typically put the letters earlier in the alphabet before the other letters. And the last term, b squared times b squared. Multiplying two things with the same bases, you're going to add the powers and get b to the 4th. Combine like terms. Here, there's imaginary 1s as coefficients in front of these, and 1 plus 1 would be 2a squared b squared for our final answer like this. Let's try one more before we get you out of here. Here, I want to figure out what is this expression equivalent to. Well, of course, rewrite it. Take the first terms. 4a squared times 4a squared. When you multiply things with the same base, add the powers, but don't add 4 and 4. Those are regular numbers, they're not powers. 4 times 4 is 16, 16a to the 4th. Outer terms. 4a squared times 3 is 12a squared. Inner terms. Same product, just written in a different order. 12a squared. And the last 3 times 3, that's easy. That's just 9. Finally, combine the like terms. If I have 12a squareds and another 12a squared terms. That becomes 24a squared. So my final answer is 16a to the fourth plus 24a squared plus 9. I hope you learned something in this video. Until next time.